To begin the sourdough starter, take a cup of whole wheat flour and half a cup of water. Mix the water and flour together in a ramekin and then put it into a glass jar with a lid and close the lid so that it's slightly tight and put it in a warm temperature. Sourdough starters are basically small examples of natural selection. Microbes, which are derived from anything from ingredients to environment, grow when flour and water mix together, ultimately making enzymes known as amylases that are found in flour convert long starch molecules into simple sugars. These simple sugars are what the microbes in the starter feed on. As the starter grows, bacteria fight for survival. Certain bacteria, known as lactic acid bacteria, make the starter so acidic by producing lactic or acetic acids that only lactic acid bacteria and acid-tolerant yeast can survive. The two different forms of lactic acid bacteria are homofermentative and heterofermentative. Homofermentative lactic acid bacteria only produce lactic acid, which has the formula of C3H6O3, and have dairy-like flavors. Heterofermentative lactic acid bacteria produce lactic and acetic acid, which has the formula of CH3COOH, ethanol with the formula of C2H6O, and carbon dioxide with the formula of CO2. This lactic acid has a sharper, more vinegar-like taste due to the acetic acid. The most common of the lactic acid bacteria is the fast-growing Lactobacillus sanfranciscensis. The increased acidity, furthermore, activates the enzyme of phytase, which makes certain minerals more accessible. Lactic and acetic acids that are produced by the bacteria lower the pH of the starter to around 3.5. The lowered pH gives the sour flavor of the bread and also helps to eliminate pathogens in the starter. When the starter is fed, alcoholic fermentation takes place. Alcoholic fermentation is a process in which simple carbohydrates are converted into CO2 and ethanol. This can be explained by the equation C6H12O6 yields 2C2H5OH plus 2CO2. To feed the starter, take a cup of unbleached all-purpose flour and half a cup of water. Repeat the steps from day 1 while also taking out half of the starter from the first day. Keep feeding the yeast for an additional 14 days until it becomes mature. After that, if you want to keep the starter active, continue feeding it for as long as possible. Prepare a stand mixer with a dough hook. Add 3 cups of bread flour, 1 17.6 ounce tub of unsweetened Greek yogurt with active cultures, about 1/2 to 1 cup of sour cream, 1 teaspoon of salt for taste, and a scant 1 teaspoon of yeast. In sourdough bread, the key ingredients are flour, which acts as gluten, a starter or leavening agent, such as yeast, sugar with the formula of C6H12O6, salt, which is used for taste and has the formula of NaCl, and water, which has the formula of H2O and is necessary for a variety of processes. However, if too much salt is added, the reactions in the dough while baking will slow down. If the reactions slow, then the sourdough will have less crumb, be more dense, and will not rise properly. Thus, a very small amount of salt is recommended. In this particular sourdough, yogurt was used instead of an actual starter, though the starter is still shown in the beginning. The replacement of the starter with yogurt makes for a quicker dough that still creates the same product. The reason why this replacement works is due to the yogurt boosting the bacterial content of the dough, since a multitude of the bacteria found in the starter is the same as that in yogurt. Flour is composed of proteins as well as small starch granules. These granules are made up of a mixture of molecules, notably amylose, which has a linear structure with the formula of C6H10O5N, and amylopectin, which is heavily branched and has the formula C30H52O26. Both of these molecules are polysaccharides, which are long chains of polymeric carbohydrates made up of monosaccharide units. The arrangement of these molecules and their proportions depends on the type of flour and how it behaves during baking. Gluten consists of amino acids, which are types of proteins that are characterized by having long chain-like molecules built up from smaller molecules. Gluten is formed when gliadin and glutamate amino acids interact with each other in wet dough. These wheat proteins are insoluble and form associations with water molecules and each other. When water is added to flour, proteins on starch molecules absorb moisture and become sticky or hydrated. Hydrated molecules stick together to bind granules, which ultimately stretch and change shape. This process is how the gluten network forms. The gluten network is incredibly important for the dough, as it is what it expands to hold the carbon dioxide, or CO2, in baking, helping the dough rise and form a dome-like shape. Turn on the stand mixer so that the dough can knead for about 5 to 7 minutes. The end result should be slightly wetter than normal. Spray a large bowl with cooking spray. Then take the dough out of the stand mixer and place it into the bowl. Cover the dough completely with the oil so that all sides are completely covered and that the dough is round. Cover the dough with saran wrap and let it rest for 6 to 8 hours until it doubles in size. Because the dough took 8 hours to proof, Mia Jones and I got a little bored while making the dough. Thus, we decided to go skiing at Yawgoo Valley on the day it opened, so here's a clip from that. After the dough is doubled in size, turn it out onto a floured surface and knead for 2 to 3 minutes. After it has been kneaded, turn it back into a ball and then put it into a bowl for an additional hour to 2 hours so that it can proof for a second time. Kneading is incredibly important for the dough structure. The process of kneading the dough before or after proofing helps to promote gluten formation. Kneading helps to activate the growth of gluten so that it can help the dough rise in baking. Kneading also adds oxygen and energy into the dough, which speeds up the gluten developmental process for faster baking. It helps redistribute the yeast and sugar while also regulating the temperature of the dough. The purpose of proofing is to primarily activate the yeast in a dough. During fermentation, which happens in proofing, yeast cells consume carbohydrates to produce CO2 gas, which helps the dough expand and rise. Fermentation is essentially an enzyme-controlled breakdown of an energy-containing compound, such as carbohydrates into the CO2 gas and an alcohol. Some important stages of proofing are autolyse, which occurs after flour and water is mixed, where enzymes break down starches into simple sugars for the yeast to eat. Another important process is in bulk fermentation, which is the long proof after the yeast is added to the dough. Bulk fermentation is when yeast consumes sugar to create CO2 bubbles that inflate the dough. Proofing is incredibly important for the structure of the dough. Underproofed dough will not expand as much due to the gluten network not being formed enough to hold bubbles and pockets of air. This can cause a tight crumb and a very dense bread. Overproofing, however, can cause the entire structure to collapse, with the gluten structure being too thin to hold the pockets of air. During actual baking, steam from the water content in the dough condenses on the top of the cold surface of the bread. This steam delays crust formation, which helps create a last fermentation process while the bread is still in the oven. This last fermentation creates more bubbles in addition to those already formed while also expanding the dough so that it rises. A Dutch oven or pan with a lid is typically used so that the evaporated water vapor is caught, keeping the condensed water on the surface. Under heat, the CO2 gas and the bubbles of the bread expand and blow the gluten network up like a balloon. The thinner the balloon is, the more expanded the gluten becomes, the more the bread will rise, creating a dome-like appearance. When the cover is taken off of the pot the bread is in, the Maillard reaction can finally occur, hardening the bread crust. After the dough has undergone the second proofing, turn the oven to 450 degrees Fahrenheit and place a covered pot into the oven for around 45 minutes so that it can heat up before you put the bread in it. In the baking process, the Maillard reaction is also present to brown the sourdough and give it its distinct flavor and aroma. The Maillard reaction occurs when proteins, also known as amino acids, and sugars, largely derived from carbonyl compounds, are broken down at high temperatures when baking. These sugars and proteins are derived from the flour that is used, with certain types containing more proteins than others. In sourdough bread, all-purpose, and whole wheat flours are used, all of which have high levels of protein. These flours help with the starter, the rise, and the coloration of the bread in the Maillard reaction. The Maillard reaction ultimately produces ring-shaped organic compounds that darken the surface of the bread, giving it the golden brown appearance. After the dough is doubled in size for the second time, place parchment into the pan that was put into the oven. Then, carefully, overturn the dough from the bowl into the pan and place it in the oven for around 30 minutes covered. And after 30 minutes, take the cover off and bake for an additional 10 minutes. During actual baking, steam from the water content in the dough condenses on top of the cold surface of the bread. This steam delays crust formation, which helps create a last fermentation process while the bread is still in the oven. This last fermentation creates more bubbles in addition to those already formed while also expanding the dough so that it rises. A Dutch oven or pan with a lid is typically used so that the evaporated water vapor is caught, keeping the condensed water on the surface. Under heat, the CO2 gas in the bubbles of the bread expand and blow the gluten network up like a balloon. The thinner the balloon is, the more expanded the gluten becomes. The more the bread will rise, creating a dome-like appearance. When the cover is taken off the pot the bread is in, the Maillard reaction can finally occur, hardening the bread crust. After the dough is finished baking, take it out of the oven and put it on a wire rack for around 20 minutes until it cools completely. Then it is ready to be cut open.